We're dancing on tables till I'm on my face with all of my people, and it couldn't get better, they say. We're singing to last call, and it's all out of tune. Should be laughing, but there's something wrong. Ellie hits me when the lights go on. Maybe I miss you.
All right, so we're going to go over the in-service here on our new gas meter. Okay, it's the Altair 5X. 5X. For those of you who weren't sure, the current meters that we have are the Altair 4X. Actually, we have the Altair 4 and the 4X, but they're basically the same. So this is what we currently have, several of, and this is what we have now, one of. Okay, the Altair 5X, which is this bad boy right here.
That's on the engine?
Yeah.
What's the difference between, what's the 5 have that the 4 doesn't?
Oh, that's a great question.
Spence is gonna kill us. You like Scott Steve or do you like MSA?
I've always been in MSA.
All right, picking up where we left off. Little fella had asked the question what the difference was. This is a good segue to why the switch and what's the difference. Well, for the most part, our old meters is getting old. The sensors are going bad. The sensor life on our old meters did not last very long.
Well, I was just looking at, because it's 4X and now it's 5X,
Yeah,
right?
right.
So with the number increase, that's what I meant. I know they're old, but I'm just seeing what
Yeah, you'll see. I'll show you here in a second what the
Okay.
specific differences are.
Yeah.
But this is part of the reason why. It's because the sensors were going bad. The Altair 5X has the ability to monitor a total of 6 gases, okay? Where the 4Xs only did 4, okay? And of course the big one is that the Altair 5X can monitor for what are called VOCs, or volatile organic compounds. And they do that by using what's called a PID, or Photoionization Detector. All right, someone's missing a head there. That was Matt. So you know, Matt and Mike know that they laugh until the other departments don't have PIDs, right? So the difference is specifically that, you know, I already talked about the sensor life. We have an increase in the sensor life to about 3 to 4 years. It varies on the sensor. We all know that the old meters are supposed to be in the room for about 30 to 60 seconds to get a full reading. Not anymore, you got 15 seconds. The calibration is a lot easier. It uses a lot less calibration gas. And there is some Bluetooth capability to this meter. Okay. All right. We know John DeMarno is a big fan of, or not a big fan of, photoionization detectors, right? What's this thing with photoionization detectors? What's the smoke detector issue that John has? Well, the entire fire service, not just John. Nobody knows? What detectors are we, smoke detectors do we encourage people to buy? Photoelectric, right? Instead of ionization, right? So, anyhow, we're going to talk a little bit about the actual PID itself. I'm not going to get into we don't need a technical background here as to how a PID works, but for the most part, it's going to use a light source that emits ultraviolet light. The gas goes through it, it knocks some electrons off, and in the process of doing this, it creates a reading. That's all you really need to know. Okay. Notice here it says exciting, and you see the excitement on your face when I talk about it. It is very exciting.
John looks excited.
John looks very excited. You can see how excited he
Not
is.
for Murder 1 or something, something like that. Jeez.
And of course, the PID is good for measuring volatile organic compounds. All right, remember ionization potential? Remember this exciting topic that we just talked about that we could locate in the back of the, or in the NIOSH book, right? So what an ionization potential is, and you can read this if you want, but for the most part, not all gases can be ionized. So that means that this thing here cannot see all VOCs, okay? the ionization potential, and this is very important, the ionization potential for the gas has to be below 10.6 electron volts for this PID to see that gas, okay? There are different types of bulbs that are available, but the 10.6 bulb is the most common, all right? The 11.7 bulb is out there, but the shelf life of the thing is like 3 or 4 months and you have to replace it. So typically hazmat teams and fire departments use the 10.6 bulb, okay? So just remember that, because when you go to a scene, you're not sure what you're doing, it's gonna look bad, right? So if you know the name of the gas, and you know that its ionization potential is above what?
10.6.
What happens?
It's invisible.
It's invisible, you can't see it. Okay, so that includes stuff like carbon monoxide, oxygen, right? These things that we already have the ability to meter are not visible through the PID, all right? Extremely importante. All right, so let's get to this volatile organic compound thing. Sounds pretty scary. But volatile organic compounds are things that, it's kind of like a broad umbrella of stuff. Generally speaking, these are chemicals that have a high vapor pressure. What is considered a high vapor pressure?
40.
That's right, above 40 mils of mercury, right? So, someone's paying attention. So above 40 is considered a high vapor pressure. So these are very unstable chemicals. They include gasoline, epoxies, resins, hydrocarbons. We'll see another list here in a second. It's the long-term exposure to these things that can really be bad, but there are some things that are acutely toxic to us in small amounts. We'll talk about those later. They tend to have carbon in them, but anytime you smell something from a liquid, whether it's like nail polish remover, acetones, paint thinners, things like that, those are all things that are giving out VOCs, all right? The NIOSH book itself will not be able to tell you up front that it's a VOC. Okay, you're going to have to try to figure that out to some degree on your own. This is just a list of stuff here. There's a lot of shit here, but benzene, toluene, right? Xylene. We're going to get to some of these in a little bit more detail later, but this is just a list. I mean, paint strippers, degreasers, aerosols, mothballs, refrigerant, aerosol sprays. You know, when you get new carpet, right? You roll that new carpet out, it's got that smell, you're like, oh, new carpet smell. Those are actually VOCs that are harmful. They are harmful. Which is why we know that when that stuff burns, right? We'll get back to the whole modern fire behavior, which is why that stuff is bad, okay? Formaldehyde. Mike knows about formaldehyde.
More about lying.
Right. All right, here's a little trick for you. If it ends in "ene," it could probably be seen by the PID. Just because it doesn't end in "ene" doesn't mean it's not a VOC, but if it ends in "ene," that should be a good hint that this little bad guy here, see how scary he is? It's very scary. But some of these things here are examples of VOCs. It was a news station or something, did a study of some of the transports near Cincinnati of the top 5 most dangerous spilled substances. We have phenols, methyl methacrylate monomer, xylene, don't forget to remind me about xylene, styrene, and ammonia. Almost all these are VOCs, okay? Why is this important? Because the 4-gas meter that we have right now will not identify this stuff. So I'm showing you 5 of the most dangerously spilled substances, and the most of them we cannot see with our 4-gas meter, which is why this thing is important for us. All right, I don't know when I'm getting to it, but I just want to point out something. Oh, it's coming up, it's coming up. All right, so here's another good example of why having a PID is important. All right, we all know gasoline, right? Gasoline, we're familiar with gasoline, right? The LEL for gasoline is 1.4%. What does that mean?
14,000 ppm.
All right, but what does that mean, though? We know it's 14. Hold on to that. What does that tell us? 1.4%.
Numbers low, so it's more volatile.
There's a low concentration of it, right? That's to tell us at the bottom, the UEL, right? Or the LEL, I'm sorry. So remember that, right? So if we take 1.4%, we turn it into parts per million, that means 14,000 parts per million, right? 1% is equal to 10,000 parts per million. So far, are we good? Okay. The lowest our 4-gas meter can read, right? The LEL on our 4-gas meter, what's the lowest it goes? When you read it, what does it say on there? 1%, right? 1%. 1% of the LEL in this case is 140 parts per million. So far, so good, right? Are we still on the same page? So that's the lowest that our gas meter will receive. The LEL will alarm at 10% of this. Right? That's when the LEL alarms at 10%. It'll go beep, 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 or whatever it does. So 10%, which is 1,400 parts per million. So far, so good? The time-weighted average, which we'll talk about what this is a little bit, is 300 parts per million. The short-term exposure limit, which is a 15-minute exposure, is 500 parts per million. You have your meter right now. You have the 4-gas meter. You walk into a room, or you walk into an area that has gasoline. Oxygen is fine. The LEL is not alarming. Are you safe? You don't know, right? You would think that you're safe because there's no alarms. But you actually could be exposed to what? This. But you don't know it because we don't have a PID. Now we do. See how that works? Is that not exciting? You seem angry. Right? Does that put into perspective why the PID is important? Remember, the 4-gas meter has limitations. It can only tell you what it's designed to tell you. It can tell you what the oxygen concentration is. It can tell you whether or not there's an explosive atmosphere. It can tell you how much carbon monoxide we have. And it can also tell you how much hydrogen sulfide we have. But it can't tell you anything else. Okay? That's why the PID is helpful. All right, so we're just going to review the basic operation of how this thing works. There are some limitations. Of course there is, right? One of the biggest limitations is that this meter, once it's turned on and once it's doing its thing, it will not tell you what it's reading. It does not know that. So you can't take this into a room and there's an unknown odor. It can't tell you what's in that. You can't specifically tell you that, which is okay. We don't care. But just the expectation is that don't think this is going to tell you what gas is in there. Okay, it won't do that. These are some of the things that it cannot detect. Okay, which is okay because some of the stuff we can detect with the 4-gas meter as it is right now. Those same things are on this. Okay, the same sensors that we have on the Altair 4X are the same sensors we have on here, except for the PID. Right?
So it can't detect.
So it's not going to detect oxygen.
There's an oxygen sensor on here. It will detect oxygen, but the PID won't detect oxygen. Does that make sense?
This is a visual.
Sorry. Yeah. But we have an oxygen sensor on here. It's just that the PID cannot detect oxygen. And of course, remember 10.6. Any gas of 10.6 or above, the PID cannot see. Right? All right. This, the meter and all our meters fall under our two abilities to identify and isolate the chemical, right? We're going back to that. That's back to our awareness. All right, I'm going to give you a little scenario here. And using this scenario, we're going to use this scenario to understand the basic operation of the meter. All right. Here we are. 17520 Angle Lake Road. Employees getting sick. There's a strange odor. Ooh. Ooh. This would fall under what's called the sick building syndrome. Right? Sick building syndrome. Or a smell that we've had over a couple of days. We had this over at just recently. Where was it at?
Social
At the Social Security office, right? We didn't have the PID at the time, okay? But these calls, they come in, right? And this is the thing that we're concerned about. This would be a chronic exposure, right? If this is something that's been going on for a couple days, it's been going on for a couple weeks, they don't know where it's coming from, this is a great way to try to pinpoint where it's coming from, okay? So sick building syndrome. All right, so 17520 Angle Lake Road, employees getting sick, there's a strange odor. What is the appropriate level of PPE to wear to this call?
SCBA.
Here's a couple of options. We got this guy here. I have no idea who he is. I found him on the internet. Doing this search, not any other way.
Searching guys, huh?
Right shape. All right, so there's this guy right here, okay? So we got this guy who appears to be in his bunker
Randy.
coats. We got this guy here who appears to be fully ready to go. And then we got this guy here who's not in his SCBA, but he's got all his other cool stuff, right? All right, so what's the appropriate response to this call?
SCBA.
We got one vote for SCBA.
Well, guy to the right.
You like this guy here? Okay. I'm not saying there's a necessarily wrong or right answer, but what you shouldn't do is this, going up to the door and, right? But you're gonna say to yourself, well, self, they've been in the building for days, right? That's the first thing you're gonna say. They've been in the building for days and, you know, they're exposed to it. Yeah, they've been in the building for days. They've been exposed to it. Is that what you want, to be exposed to it? I sure as hell don't, right? They called us for something. I'd rather not be exposed to it, right? Because remember, exposures for us, it's a cyclic thing. We respond to these calls time and time and time again. Over time, the more exposure we get, the worse it gets, right? So even though this may be a one-time thing for us, this particular moment, it's the accumulated exposures that we're concerned about, right? All right, so we've picked our PPE. We gotta do scene size up, right? If people are reported to be ill, you gotta wear a CBA until told otherwise, right? Make sure the building's evacuated. What else do we wanna do for scene size up?
DS sheet.
Right? Which are now called SDS sheets, in case you're wondering.
What are they called now?
SDS.
SDS.
Yeah, so that's a good thing to do. We're gonna pull that up, okay?
Your property maintenance there.
Okay,
Called a hazmat team.
you can,
Go get the manager, see what's going on. There's
Okay.
lunch over there.
all right. All right, these other things you think important?
What do they do at the building?
Okay, so the occupancy, right, that's good. There's a lot of information gathering that occurs at this point for us to develop a plan, right? Although this bottom one can be rather tricky, right? There's immediate life safety. Remember these 5 things, right? We're still in this process. We're still trying to recognize and identify. We're on step 2. Notice we're on step 2 here. We have not even turned the meter on, right? I don't know if you guys have noticed that. We have not turned the meter on yet, but we're on step 2. So there's a process to this. Is there a life safety hazard? Now up there it says go get them. What do you think about that? There's a life safety hazard. What would be your determination on whether or not you could go in, rescue, and come out?
Have a meter on.
Okay, that's one thing you could do, all right. But what would you do with that meter? What would be your go or not go decision if you're using the meter? What would you see on there that would be like, you know what? I'm good.
LEO,
Okay?
it's an alarm, you know.
The alarm's at 10%. You're not gonna go in? Who would go in at 10% LEL?
Depending on what the chemical is, or the gas is.
Do you see where we're coming across a problem here? What's the answer to this question?
Gotta identify what's causing the issue.
What would be the factors that you would use if it was a fire?
Like if there's a survivability.
Right, so are they survivable? How different is this hazmat incident between a structure fire? They're really not.
No different.
There is zero difference.
I'm more familiar with the fire.
We're more familiar with it, but it's hazmat. It's like, whoa, hey.
Kind of see the hazards. If
Yeah,
the
you're like,
building's-
wait a second, hazmat. Let's step back. But how many hazmats are inside of a structure fire?
Oh.
Tons. But we do not hesitate to go in and do what we have to do. But the environments are relatively the same, except for maybe the heat and the smoke, right? That's the process that you have to start thinking of when you're trying to determine whether or not to go or not go, okay? If there's a life safety hazard, they're survivable, the risk is what? What's the risk? Is it a high risk, low risk? It's a high risk, right? What do? We risk a lot to save a lot, and we risk a little to save a little, right? All right, so that's part of the determination. As this is going on, we could try to get the chemical name, try to get some information, right? We talked about SDSs, the management team interviews, all that stuff is done here, okay? But with time not being on your side, treat it like a structure fire, okay? There are some incidents clearly that would be bad, but for the most part, right? Are we following this process? Do we get this? There's no real, this is a gray area. There's nothing that I can tell you is right or wrong. But I think what helps is treating this like it's a structure fire instead of treating it like it's, a hazmat incident. All right. Here's a few points to remember when using the meter. All right. The Altair 5X is approved for atmospheres up to 21%. Doesn't mean you can't, but the LEL is not going to work if the oxygen is too high. Okay. The oxygen has to be greater than 10% for the LEL to function. I usually tell people if the oxygen sensor is not within the normal range, do not use it, do not enter. Okay? Unless there's a life safety hazard. For our purposes, there really is no point to enter an atmosphere that's oxygen deficient. Okay? But remember, if it's not greater than 10%, the LEL will not work. The PID will read in 0.1 parts per million up to 999, and then past that it'll read in solid whole numbers. Okay? You understand what I mean by this? So once it gets to 999, it'll just be 1,000, 1,001, 1,002, 1,003. There won't be no decimals. Don't use them in atmospheres that contain combustible or airborne mists or dusts. Right? That's the same for the Altair 4X. You shouldn't use those in that type of atmosphere. And don't use them for atmospheres for combustible gases that have a flash point greater than 100 degrees. It has a very difficult time. The LEL has a very difficult time identifying those types of chemicals. And how would you know that the flash point is above 100 degrees for the chemical?
Your book.
In the NIOSH book. Not the ERG, but the NIOSH book. Okay?
Don't they have that in there?
No, they won't tell you the flash point. Some of them very generically might, but. All right, so finally we're going to turn the meter on. All right, who wants to be our guinea pig? Don't worry, it will survive a 10-foot drop test. But don't turn it. Turn it off. There's a few things that are different about this meter than with the Altair 4X. Okay, and you'll see as we do this.
We need a password.
Yes, it's iScan. All right.
Right.
As you're turning the meter on, as you're approaching the scene, you have to make sure you're in a what?
Fresh air.
Fresh air, right? Does the engine have fresh air? Typically?
Best
No.
you can get.
Yeah, depends on who's driving. And whether or not they are methane infused. But generally speaking, the engine does have fresh air in it, and you can turn the engine on, or turn the meter on the way there. The thing is, it takes so long for this thing to boot up, like I've checked it before, it takes about 2.25, 2.5 minutes for it to go through its entire boot process. So that's a long time to be waiting on scene when people are coming up to you and they're like, hey, right?
Is it longer than before?
It's about the same, about the same. All right? So try and do this as soon as you can. All right? I'm telling you it's 2.5 minutes, but when I've checked, it's been about 2.25. So under promise, over deliver.
Randy's motto, huh?
Right. Okay. So Ricky, are we queued? Not yet. So the big difference in turning this thing on, right? We got to be in fresh air. We already know that. But what you're going to have to do is you're going to have to cover this port with your finger, or it'll alarm. Okay. And that's done to test that port. So go ahead and turn it on. And it'll prompt you to test the port.
That's more Randy's thing, huh? Holes and fingers.
Like I said, it'll take about 2.5 minutes or so to go through the process. All right. The noise will change. There you go. All right. Eventually, you'll get to the point where it provides for a fresh air setup. The screen on there is exactly the same as the screen you see. Well, I did a hand up there. Now, as it's going through the cycles, you'll see where it says short-term exposure limit and the minimum alarms. The short-term exposure limit is a 15-minute exposure. The TWA is the time-weighted average. That's for an 8-hour period. Okay, so those are two of the different types of alarms that could occur on this meter. So short-term, 15 minutes. Time-weighted average is 8 hours. Good. So you saw the fresh air setup, and there's a yes or a no option, right? You just click the power button below the appropriate one, and now you're in metering mode. Okay.
It'll automatically do it if you don't hit anything.
Yes, it'll default to the previous fresh air setup. Okay. I would not trust that one because you have no idea who turned it on last, where they were at. Okay. As you see up here, there's a capability for a 6th gas, which would be right here. I was working on trying to figure out what that sensor should be, and then this thing showed up. So, don't know what happened there. Either way, one of your handouts, and I have a strong suspicion that you guys are definitely going to engage in this, but this handout shows you the other available sensors that could be put in here. If for some reason in your research or your trials and tribulations on the job here that you may come across what you would think would be a good 6th sensor, let me know. But this is what's available. Okay.
What's the most common out of this?
That's the whole. I have a commodity study that the chief did, And he has chlorine on here as the most, for carloads, for fuel, for, I believe this is the rail. So that's one option, to target the most commonly used substance. The other option is to try and figure out if there's something in the city, commodity-wise, that is more common that we would have a better chance of running into. I still have not seen something that I feel meets that criteria yet, but the default would be chlorine. So,
Plus we have the pool.
yeah, so there's that. Okay? So far, so good over there? All right, so, oops. All right, so as you're using this thing, you're going to get a confidence light here that's going to beep every, it's like 15 seconds or so. That just lets you know that everything is running smoothly, the port is not blocked, everything is okay, all right? You also get that beep, right? That's normal. The blue light blinking there on the side is the Bluetooth active mode, all right? We'll talk about Bluetooth in a little bit. And these lights will light up when that beep occurs. So these are all the things that are telling you that everything's status quo and you're ready to rock. All right, so we're going to get a little technical here, which I don't really like to do, but we're going to do it anyway. We got to get into correction factors. Although you might like part of this. I feel like you might. What are correction factors?
Conversions for each of the different gases.
Right, we are supposed to be using correction factors with the Altair 4X, depending on whether or not we know the substance that we are metering or measuring, whatever term you might use. All right. So correction factors, we have to apply these if we know the gas. Okay, so far so good? Here's our Altair 4X. These are the correction factor numbers. As you can see, all of these here are under 1.0. That is important because the reading that you're getting on there actually means it's higher than the actual concentration of gas. Okay? Do we understand that? You know what I mean by that? So if you were to know that you're reading methane, which is a primary component of
Randy.
Yes, natural gas is primarily composed of methane. So for all intents and purposes, if you are metering natural gas, the reading you get on there should be multiplied by the correction factor, which is 0.5. So the reading you see on the Altair 4X and on this one is actually half, okay? Now, I don't make these things super known because I try not to confuse everybody. So there's a built-in safety factor here, right? Right now, if someone were to use the meter and it was going off, and they were metering natural gas, they would actually be exiting with a safety factor of 2 to 1, right? Because the atmosphere is actually 50% less as dangerous as they think it is. So I'm not super concerned about that. What I am concerned about is numbers that are greater than 1. Okay? Greater than 1. And in this case, there's only one, and that's xylene. If you remember that little study that I showed you with the chart that had the 5 most dangerous spilled substances, xylene was one of them. Okay? Our meter is 2.5 times less responsive to xylene than it should be. Okay? So if you know that you're metering xylene, that's the one chemical you need to know in order to make sure that you are not in a dangerous atmosphere, or more dangerous than you think it is. And that's xylene. Right? So if the meter reads 10, what is it actually metering?
20.5.
Correct. Okay? So just do the math. All right. Just a little refresher on the LEL and what the LEL means, right? This particular sensor here, the LEL sensor, measures how close to the lower explosive limit you are getting for the gas that the meter is calibrated to. Okay? Do we understand that concept? So the meters calibrated to, for LEL, pentane? I'm trying to remember. Either way, it's basically telling you how close to the lower explosive limit you are, right? If it says 10% of the LEL, you are 10% towards getting to the lower explosive limit for methane, which is methane mixed in air, 5%. Not confusing you yet? So if there is 5 to 15% of this room is filled with methane, it is in the flammable range. What the meter's telling you is how close to that 5% you are getting. Right? Does that make sense? All right. Of course, you have to apply the, if you know the gas, then you can multiply that math times the LEL, it'll get you your lower explosive limit. The easy way to figure this out is, if the LEL is learning, you should get out. Simple as that. Is that an easier way? Okay, here's another strong point to remember. If the LEL reads XXX, XXX, yeah, 3 X's, that's bad. That means you are in the flammable range. So you're in that 5 to 15 range, you need to haul ass out. You should not be in there. Okay?
Do the lights change colors or anything?
It alarms.
Just a
Yeah.
red.
Yeah.
I was gonna say it was hungry.
Randy, about 5 there?
I think she's getting chased by Randy for the camera.
All right. So there's a little bit of a bonus. There's a little bit of a bonus when it comes to the PID part of the Altair 5X and correction factors. Okay? Here's where it gets easier. This is about to get easier. The Altair 5X allows you to pick a chemical that already has all this stuff predetermined in it. Okay? So there's no math, there's no nothing. You just go to the screen, and it shows you how to choose it, and you just choose it. Which I'll show you here in a second. Hold on one second. Of course, it's not going to rotate. Okay. I want to go back to the beginning. So, here's what's going on. So we know the name of the chemical. Okay? One of those opportunities where we know the name of the chemical. You're going to go to the meter, and where my thumb is there, that left button, you're going to press that down. Can you see that on yours right now? You're going to press that until,
What does that say, pump?
yeah. All right, right there where it said change VOC gas, where it's blinking, you click yes, and right there,
Zip it.
I don't know if you heard that or not.
What did he say?
Zip it.
The peanut gallery had a comment.
Zip
You
it.
heard that?
Who says that?
It's Stumpy.
What was it?
Turn the effing thing off. The beeping's in
Oh, that's right, that was at night.
Yeah. All right. So you understand how, okay, so you know the name of the gas. All right, that's important. So you know the name of the gas. You're going to cycle using that button until you get to the page where it said change VOC gas. Change VOC gas, and right here are the top 10 most, your favorites, our favorites, the default favorites. If it's one of these, you just click one of those, and you're good to go. Okay? Click yes, accept, whatever, and you're metering for that gas. If it's not in these list of favorites here, you go to all gases, click on all gases, and you can cycle through the gases until you find the one that you're looking for. Okay? So remember, this is a huge change, and this is very different from how we operate with the Altair 4X. Okay? This change is so that if we know the name of the VOC, we can change the meter to read specifically for VOCs on the PID. Okay? You understand that concept?
Then you can't.
Once
You have to know
click
that,
on the
yeah.
gas, okay, then what's it come up on the screen?
It won't. It'll just go back to metering. It'll go back to reading.
And then it's just only reading for that.
Yeah, the PID is reading specifically for that gas. Correct. Just the PID part. Everything else is still the normal. You're still reading oxygen normal. You're still reading LEL normal. All that stuff is going on normally. But the PID sensor is specifically reading for that gas. And it'll alarm for the certain numbers that are dangerous for that particular chemical. Okay? Is that, are we cool with that? Because like I said, it's a huge change for us, and it's different. Okay?
You said earlier, if you don't know what it is, it's useless because you have to.
It's not useless. Using the PID is not useless. It'll just show readings in parts per million
Of something.
of something. So you know something is there, and that's good enough. Now the other point to that is you could use the meter as like a Geiger counter. So if you come into a room, you're reading for VOCs, and you're sitting there holding it, and you're moving around, the number's getting larger, then that means you're getting closer to the source.
So is there like a default all, or you
No.
just leave it on where it
Yeah.
is?
Mhm. Again, it's calibrated to whatever the VOC cal gas is, which I think it's isobutylene. So. All right, so we've gone through the whole process, right? We've done our size up, we've turned the gas on, we've done our fresh air setup, we've confirmed that the lights are blinking every 15 seconds to give us the confidence light that everything's functioning properly. We've done our finger test on the port to make sure the port is working properly. Okay, we either know or we don't know the gas. So we're in the middle of monitoring. You want to monitor for about 15 seconds in each area. If the atmosphere gets greater than, if the LEL gets greater than 25%, you need to leave. Okay? And the atmosphere has to be adjusted somehow. That's in our SOG. All right, so before we get to shutting down the unit, is there any specific questions so far on how the unit operates? There are other menu options in there that you really don't need to fiddle with, okay? But we'll talk about a few of the features, so to speak, here in a second. Anything?
Just gotta work with it.
Yeah, it's exactly correct. You just gotta get comfortable with it. You know, a new piece of equipment like this, it's a little bit different, does take a little bit of time, so just keep that in mind. So there are some other features and functions. What about bump test and calibration? So let me give you an example here of what a bump test is and a calibration. So, bump. Basically, let's go, I can't even think of anything right now. I don't know, I'm trying to remember what the CO numbers are. Let's just make something up. Okay. So what a bump test does is, before you leave to go on a call, you would put the meter inside this machine, and it would send a reading of CO in this range to the machine to test it, to make sure it's working properly. And it does that for all the sensors. Okay, just make sure it's working properly, that's it. It takes about 15 seconds. Calibration, on the other hand, is done to make sure these numbers are correct. Okay? That's the easiest way to describe it. So bump test, make sure that it reads in the proper range, and a calibration, make sure that the range itself is normal. This does not affect us for the most part. but for Ricky doing the calibrations, it does. However, this
I thought
new
you
system,
just said we're supposed to do that before we go on.
you're supposed to. Before, it just took a long time to do a bump test, so it really didn't make a whole lot of sense. Right now, I'm still trying to figure out whether that's going to be part of how this works. I haven't figured it out yet. But theoretically, you should bump test it before you respond, or bump test it in the morning if you're on the engine. But I'm going to work on the details for that once we actually get this machine. Because what this machine will do, this will actually calibrate the unit and bump test it automatically every morning. Or you could set it to whatever schedule you want. We do not have this yet. So that's a key component to the fact that we can't calibrate this unit or bump test it yet until we get this. So that's still on the horizon. So I'm still trying to figure out how that's going to work. If the meter, but the other problem is the meter has to stay in here. So you would have to remember to grab the meter. You know, would you just calibrate it and bump test it in the morning, then pull it out? You know, that's all these things that we kind of got to work through. Okay. All right, the instant alert. Okay, this is basically like a pass device. So if you push and hold for 5 seconds to activate the alarm there, the down button, go ahead and try that. There you go. All right. So if for some reason your pass device is not working, you could use that. The other thing is the motion alert. So this is basically another pass device, but it would alarm when there was no movement for 30 seconds. I currently have this feature set to off. I think that would just get kind of annoying. But if you guys feel like that's something that you want, you think it would be helpful, then just let me know. But like I said, currently it's set to off. There is the ability to connect this to a Bluetooth compatible device. However, it will not connect to an iPhone or an iPad. I don't know why. It only works on Android. So the app is called Altair Connect. You can download it on Google Play right now if you'd like. And it will connect to this after you set, all you gotta do is hold them together and connect them like you would a normal Bluetooth device. There's a process on here that you can go through. When you're scrolling through, you just go to Bluetooth, and it's pretty self-explanatory from that point on. I tried testing it the other day to see the signal and how it's not. I still got to practice with it a little bit. I left it in the lieutenant's office, and by the time I got to the locker room, it was dead. So,
What's the point?
yeah, but it is cool. I mean, it is, site to site. If you're outside, I can see it would probably work, but I have not experimented with it up to that point. All right, there's a couple of other things here. So, in this corner here, you can either see this, I guess that would be a yellow heart, and a red heart. If you were to see the yellow or red heart, that lets you know that the device that's yellow is approaching, the sensor is approaching the end of its life. Okay? So let myself know that the sensor is approaching the end of its life, so we can order a new one. If it's red, that means it's at the end of its life. Okay? And that means it's bad. I believe when it's at the end of the life, it won't let you use it. I would hope, though, that this came on first so that we would have got it taken care of before it got to the point where it was at the end of its life. Okay? All right. Any questions? Any questions on VOCs?
Where on the screen does it read the VOCs?
Bottom left.
How long does the battery last?
It'll last about 12 hours.
How much was it?
I don't know. I want to say they were like 2,500 maybe.
Is there a wand or anything?
There is. I've debated whether or not to put the wand on, but the wand would be useful for pinpointing stuff. I just wonder if it'll get lost or broke. It's not super strong. They use the wand typically for other. It's not fire service, that's using that typically if you're going to use, if you're in a confined space or things like that. Another good use for this would be FIU. A lot of flammable liquids that are used to start fires or could start fires are VOCs. That would be difficult for a 4-gas meter to find. So this would be a great tool for FIU to use.
Problem is, like you said, so many building materials have them.
Yeah.
You know, even the canine dogs, you
Yeah.
know, they hit on things that aren't even, you know,
Better
there's
than
so
nothing,
much stuff,
yeah,
like
yeah.
even in a garage. You know, a garage doesn't have gas or this, it's tough.
Let's see, the,
Why do they have to spend $2,500 to electrical?
right.
You hippies, some of that.
In this little death in the line of duty, this is a NIOSH investigation. Just keep in mind that this shit can happen anywhere, right? This thing is just telling you that this was a dumpster fire that a guy ended up dying from. Now, whether or not the meter could have been helpful here, and I don't think that I could, by default, would meter a dumpster that was on fire. But the key here is, or the lesson learned, is that you never know where this shit's gonna end up. The meters are helpful to have, they're great tools, but use them wisely.
Are we gonna do any hands-on training of this, like with scenarios, like?
I would like to
like,
at some point.
Just,
It's hard.
I know, it's
Hard to use this thing. I would encourage you guys to turn this thing on, cycle through. I would like to see you cycle through the meter to go to the VOC section where you could choose one of the gases, so you could see how that works.
Even like a flow chart would be neat, like.
Yeah, that's kind of what
you know,
this
like
is.
an ACLS like
Yeah.
this, and then now what would you do?
It's sort of what this is. This is going to be with the meter somewhere. This is just like a preliminary on how to switch the VOC. I was thinking of coming up with something a little bit more detailed than this, just with some major, like, I need to remember, you know, that the vapor pressure has to be above 40 for it to be, you're not gonna remember that. So some of those things I would like to have on a little cheat sheet somewhere. Even the correction factors, you know, you're gonna remember xylene, you know, I don't know. So,
Yeah, I have to remember along with every other.
yeah,
thing.
with all the other stuff that it's required to
It's
remember.
tough, man.
2.5.
There you go. Any other questions on our responsibilities for hazmat? Awareness operations, the 5 things that we need to know. Anything with CERT, hazmat? Questions about CERT hazmat? No?
When we call for a limited, is it automatic for what you guys bring? Limited wise, you guys know a
6.
number?
6.
6?
Yeah, the decision between what's a limited call out and what's a full call out sometimes is a question the guys have. It's hard to say, you know. If it's something major, you know, yeah. If it's not something major, you know, leaking fuel, sheen in the river, you know, that kind of stuff that we get,
Limited?
those are limited call outs. Even when we respond to structure fires, we did structure fire a couple, you know, years ago in, I forget where that was. You know, it was a structure fire, but it was like, you know, it was a still limited call out for us, because we were just metering the area, so.
The big one we were all at, that was pretty awesome.
Yeah, it was a pretty big fire, yeah. All right. Let's see, did I miss anything else here? Any other questions? All right, okay. Please go through that, try to locate the VOC and make that change, okay?
Is it my imagination? Is it something that I'm taking? All the smiles that I'm faking, everything is great, everything is great. Going out every weekend, staring at the stars on the ceiling.